A triangle is a closed geometric shape that is formed when three line segments they connect each other. So if I were to label this shape, what you see right here with 3 points A, B and C, then such a shape is called a triangle, and each line segment AB or line segment BC is called either a side or an arm of a triangle. Okay. Now since we are talking about the intersection of two or more lines, we know that whenever two or more lines intersect, they meet at a common point, and we call this common point as a vertex, right? So in this case, I have vertex A, vertex B, and I also have a vertex C. So a triangle will have three vertices, okay? Now, since we are talking about vertices, we also know that when two lines intersect and they meet at a common point vertex, they form an angle, and hence we will see three angles in a triangle as well. So let me label them as with some number as well. I got three angles in this shape. It is because of the reason of three angles we call them as triangle, alright, and hence the name. Now one thing you want to know is that there is a term called interior angles, okay. All these angles that you see, 1, 2 and 3, these are called interior angles, and simply because of the fact that they are inside this closed geometric shape, okay. And you must be thinking, since we are using the term interior, that means there is something exterior as well, and you are absolutely right. If I simply extend this line CB all the way up to the point D, and then you will see that I have now another angle, angle ABD, which is shown like this. This is my angle. Let's put this as an angle 4, okay? Angle 4 is called an exterior angle simply because it is outside this shape, right? So the exterior angle is angle 4. At any vertex, when you create one interior angle and one exterior angle, the sum of those angles will be always equal to 180 degree, simply because this is an angle of a line. A line makes an angle 180 degree at any point on the line itself, right? In addition to these basic terminology, let us also talk about what is a median and what is an altitude of a triangle. My triangle in this case is triangle P, Q and R. Three vertices, three sides, okay? Now, if I divide the line segment PQ into two parts such that it creates a middle point, and let's say that middle point is point T, okay? Now, if I simply connect this middle point T with a vertex which is directly opposite to it, this line segment RT is called the median. And median because I'm connecting the middle point of line segment PQ to a vertex which is directly opposite to it. And hence it is called a median, alright? And now if you can guess, there could be always more than one median. Simply because there are three vertices, right? And I can join any vertex to a point which is the middle point of the line segment which is directly opposite to that vertex, and that will create another median. Just like what you see here. If line segment RQ is divided into its midpoint, let's say that midpoint is S, you could connect the point P with S and create another median. So this is my another median. Okay, now let us talk about what is an altitude. Okay, if I simply define that line segment PQ is my base, okay, and this is important to know. You always find altitude of something with reference to a baseline, right? Altitude means the height. Okay, so from the line segment PQ, if I create a line which is perpendicular to the base and connects to the vertex which is opposite to it, and this angle is 90 degree, right? The vertex R meets the line segment PQ at some point, let's say point M, such that the line segment RM makes a 90 degree angle with the base, then this is called the height, or you can denote it as H, or it is also called as an altitude of triangle PQR with reference to the base PQ. Alright, so we have learned about the median, the height, and some other basic terminology. One thing I would like to point is that this height or the altitude, it may or may not be the same as the median. Because if you look at this shape, I have the median RT, which is coming from this vertex R, right? This RT is the median, but RM is the height. And these two are two different line segments or two different observations or two different dimensions, correct? Now in this case, in the triangle PQR, it is not a symmetrical triangle, hence the median and the height or the altitude, they are two different things, right? But in some cases, let's say if I take an example of a symmetrical triangle ABC, in which all three sides are equal to each other, and if I simply take the vertex A and I drop a line from there to the base, I am taking base as BC, and let's say this is the point D, and I'm saying that when I drop this line AD, which is perpendicular to the base, it will be labeled as the height, correct? Because that is our definition. But since it is also a symmetrical triangle, so in those conditions, when I'm dealing with a symmetrical triangle, the line segment AD, which forms as the height, will also be the same as the median. We will not go into the proof or the details of that, but that is something you might want to know. But for all practical purposes, I will say that it is fair to assume that median and height are two different line segments in a triangle. Okay. And with that, let us proceed to understand what are various properties of the triangles.